All right, first term I want to introduce to you is what's called an angle of elevation in a triangle. Angle of elevation. Instead of just drawing it and pointing to it, how about a little visual here with our friend Johnson? All right, here's our friend Johnson right there, huh? I don't know what he's in, but a castle? I have no idea. So if anybody knows what he's in, great. I'd like to know. But a plane was flying overhead, and once we hear a plane, what do we all do? We look up. Okay? So Johnson was staring straight ahead on what we call a horizontal line here, but then he saw the airplane. And look what happened. See how his angle changed from the horizontal straight ahead to up to the airplane? This angle right here, when I look up at something, it doesn't have to be a plane, it can be a building. What else can we look up at? Birds, thank you. That's my first example coming up. We look up, we form a new angle here called angle of elevation. All right, angle of elevation. I know some of you are just mesmerized by that. Let's do it again. There you go, looking up at the plane. Now look at what I can do with the plane. Oh, good. There you go. Oh, look. Okay, everyone, look at this. Even the head's bobbing. Look at that. That's awesome. All right, so that's called my angle of elevation when I look up at something. Now, before I end this, I want to ask you this question. Do you see a right triangle I can make here? Where this would be my angle I go by for hypotenuse, opposite, and adjacent. Right? I could just draw a vertical line straight down, and there's my right triangle. Okay, so this is your angle of elevation. You start by looking straight ahead, and then you start peering your eyes up towards the sky, and you make a new angle. All good? So angle of elevation. Let's use it in a problem with Scotty Bones looking at the bird. There you go, Brendan. See? All right. So Scott's eye level is 1.5 meters above the ground. So basically ground to his eye. That's what it's telling you, his eye level. The ground to his eye, not his height, but to his eye is 1.5 meters. And he is standing 30 meters from the tree. Scott, tree. Tree, Scott, 30 meters away. No issue so far. Here we go. The angle of elevation to the bird at the top of the tree is 36 degrees. So, Scott was looking straight ahead. Oh, hey, there's a bird on the top of the tree. Let me look up. Everyone see the angle that's formed? That's your angle of elevation, 36 degrees. All right, see how elevation works. I'm looking straight ahead, then I'll look up, and I just formed a new angle. What are we looking for? Hey, how far above the ground is that bird? All right, from bird to ground, whatever this distance is here. All right, you ready to help me? Do I have a right triangle I can create in this diagram? Everyone sees it from my angle of elevation. Whoop, right there. Oh, wait, can somebody help me? I see the angle I'm going to go from 36. I don't have any side lengths. I don't know any side lengths on that triangle. Or do I? Hi, Tammy.
The adjacent angle, or the adjacent side, sorry, is 30 meters.
If that's 30, right above, same distance, 30 meters, right? And wait, I'll have the ability to solve for the other leg, but are we all in agreement that the answer to that leg will not be my final answer? So hopefully somebody can help me out once we find the leg to get to my final answer. All right, so if I'm going from 36 degrees, can somebody please identify what the 30-meter side is and the missing X side is for me? Woo, 7, you're up. What's the X side?
That's the opposite.
Darn right it is. How about the 30?
The adjacent
Side.
or side.
Yeah, you're better than that. All right, so I have opposite and I have adjacent. All week we've been working SOHCAHTOA trigonometry. If you have the opposite and adjacent side, you can use which ratio? 5. Darn right. Tangent of 36 equals opposite side x over hypotenuse hypotenuse. Adjacent 30. Opposite over adjacent. Good, thanks. I love hearing the calculators coming out. Put it over 1. Go ahead, cross multiply like we've been doing. X will equal the tangent of 36 times 30. Is this going to be my final answer? Nope. Why am I asking that? I don't want you to do what? Don't do a darn thing on your calculator rounding it. So I get 21.79, a little more there. That's just from the bird to his eyesight. That's all that is, but I need to find bird to the ground. So to my answer right now, how can I find the bird to the ground distance? 4, Grip.
Add the eye level height to the height of the bird to his eye level.
Yep, so add in that 1.5 eye level height, and now I can round. So bird to ground, what are we looking at? 23.3 meters. Units, 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 units. You guys good there? Elevation. You were looking straight ahead, now you're looking up to form that angle. All good. All right, well, what happens if the roles are reversed? What happens if you're on top looking down? Funny you should ask, because Johnson has an answer. That's called the angle of depression. All right, angle of depression. So now he's not looking at the plane. Oh, look, there's a yacht in the water he wants to look at. So he was looking straight ahead. Let me get him looking straight ahead again. He was looking straight ahead, but then he noticed the boat, the yacht in the water. Now he turns his head down. Everyone see the angle he's formed now. Can you see a right triangle you can build off that? All right. This angle, when I look from a horizontal straight ahead down, is called my angle of depression. Angle of depression. So elevation up, depression, I look down. All good. What's up, Serena?
Will it always be at eye level?
From eye level up or eye level down, correct. That's how the angles form. Great question. Yes, it is. All good? All right. Thanks for your help, Johnson. So what about Big Al, the actual celebrity of this whole year? Angle of depression of 40. I'll get to that in a second. He's watching his friend approach the building. Huh. The rooftop, 16 meters from the ground. Can we label 16 meters? The rooftop is set 16 meters from the ground. Right, 16 meters. What else do I have? Big Al's eye level, 1.85 meters from the rooftop. Ooh, Big Al. 1.8 meters. What's the distance between his friend and the building? So everyone look at Big Al's friend and the building. See that distance between them? I want to know what it is. All right, let's get back to the 40-degree angle of depression. 40-degree angle of depression. Let me draw it out. So I know he's looking straight ahead. Big Al's looking straight ahead, and he's like, oh, there's my boy down below. There he is. See the angle he created right there? 40 degrees. From straight ahead looking down, 40 degrees. Hey, do you guys see a right triangle we could use here? I see 2 of them actually, don't you? I see one right here if I drew a vertical line up, but I'm not going to use that one. I'm going to use this right triangle to prove a point. Okay, here's the right triangle I'm going to use. You see where the angle of depression is? 40? It's outside my triangle I'm going to use. I can't use this 40 because it's not in my triangle. I can only use an angle that's inside to use sine, cosine, tangent. Can you guys help me though? Can I use this 40 to get an angle inside? Because where it is now, you're not doing opposite, adjacent, hypotenuse. Can you guys use this 40 to get me another angle inside the triangle at all? Anybody see any way I can use that 40 to figure out an angle inside the right triangle I want to use? What's up, Matt?
You could subtract it from 90 because straight across and straight down would be a 90-degree angle.
Here, you mean?
Yeah, that'd be 50.
Okay. These two adjacent angles form a right angle. Everyone, yes, it forms a right angle. So I could go 50 here. Was anybody going to tell me a different? Tammy, let's go.
Alternate interior angles.
Oh, remember that term, alternate interior? If that's 40, yeah, that's 40. Yep. Either one you want to use. Matt told me first, so I'll just use his. I'll use this 50 here. But as everyone see, you can use the one adjacent to it's complementary, adds to 90, or use the alternate interior. Your call. All right, if I'm going to use 50 on my diagram, if I use 50, what's the x and what's the other leg? If I use 50. 17, what's the 50 here? 50 to x is what?
50 to X.
If I'm using 50, what's side x?
Oh, opposite.
Opposite, and what's this other leg here?
Adjacent.
Adjacent. Lets me use what ratio? If I have opposite and adjacent, hey, 19, what ratio?
Tangent.
Tangent. Tangent of 50 equals opposite side x. Okay, still need your help. What do I do about adjacent here? What do I do about my adjacent side? Hi, Paul.
Add 1.8 and 16.
Add 1.8 and 16, 17.8. Going thug life back there, huh? With the hood today? Because you think you're hardcore?
I got a haircut.
All right, what's the big?
I'm not trying to show that.
Okay. Would anybody even notice if you didn't say that?
I'm not a big fan of it.
Can I ask why?
I think she cut it. It's new barber.
Oh, new person. Too short, too long?
Too short.
Really? Okay. All right, I'm sorry to hear that. Your professional haircut was not good. It'll grow back though, Paul, right?
Yeah.
It'll grow back. All right, so you just keep thugging it out back there for me. And no need to add or subtract anything on this one. That's going to be the side I need. I just need to round my answer. What are we looking at here? You think I have this one? There it is. 21.2 meters. Looks good. Any issues? All right, so I've shown you elevation, I've shown you depression. I just want to make sure we can do some of this stuff on our own here. How about this diagram, huh? Look at that. Anybody know that the deck at the top of a lighthouse is called the gallery? There you go. We just don't learn math in here. So a person spots a ship at a depression angle of 20 degrees. All right, so hey, they're at the top of the they're on the gallery here, top of the lighthouse. Right? Remember, looking straight forward. Oh, there's a ship coming. I'll look down at it and form a 20-degree angle. From the horizontal looking down, 20 degrees. All right, let's fill in the other parts. The lighthouse is 28 meters tall. Lighthouse. And it sits on a cliff 45 meters from sea level. So the cliff is 45 meters. And here's key that you read it carefully. What's the horizontal distance? Horizontal distance, not the diagonal distance, the horizontal distance between the lighthouse and the ship. There we go. All right, so I'm going to use this right triangle here. I'm going to let one of your classmates decide now. Should I do the adjacent angle or the alternate interior angle here? Because I can't use that 20 right now in my triangle. It's outside. Can't use it. Which angle do you want to use here? 19 again?
The adjacent.
Sure. Which would be, if you're going to use it, what is it? 70. Good. All right. Keep asking questions from people. 1, Meg, what's the X compared to the 70?
The opposite.
Opposite. And how about this other leg I'll be working with?
The adjacent.
Yep. I know this is a common theme today, but opposite and adjacent. 5. Greg, what ratio? You just answered it 2 questions ago. You good? 2 questions ago, I asked you the same exact thing. Are you good? Group, you better get them in. Reel them in here. Reel them in. Tangent. 70 equals X over, how about the adjacent side now? $73. Adding the lighthouse and the cliff. Rounding directions, nearest 1/10 of a meter. I'm at 200.6 meters. How do you feel, all right? Depression versus elevation? Oh, how about this next one? What don't we like about this next one? Anybody? Anybody? Yeah?
No diagram.
Oh, so sad. I get to walk around and critique your artistic ability. Nice. Nice. Well, you guys can just bust my chops here when you see my control tower. All right, here we go. Warm up a little here. Angle of elevation to an airplane from a control tower, 7 degrees. Here we go. Control tower, we're good? I'm good? It doesn't get any better either. Doesn't get any better. Let's just put it this way, guys. When I was in high school, you had to get an art credit to graduate. I took woodworking to get that art credit. Okay? I took woodworking because I was not touching a sketchbook or anything else, as you could see. This is about the highlight of my art career right here, drawing a cube, which all of American can do as well. Okay? So, anything else? I'm done. So the angle of elevation, again, remember, I'm sitting in the control tower looking forward. Up, there goes one of my planes. I look up and I make a 7-degree angle. All right, 7-degree angle right there. All right, a little bit more info. The tower is 200 feet high. Now here's where I just got to have you focus in a little bit. The altitude of the plane. Now what do we refer to as the altitude of the plane? That means you're on the ground looking straight above you, and the plane is directly above you. So from the ground to the plane, that's what it refers to as the altitude. That's 5,200 feet. All right, 5,200 feet. Altitude is directly above or directly below the plane. And what are we looking for? See how I changed the wording up from the last one? Last one was horizontal distance. Now I want the diagonal distance from the control tower to the plane. All right, I'll get specific, whether I want horizontal or diagonal. All right, what do you say? We know what the right triangle is going to look like. It's been all tangent today, but not anymore. What's the x to that set? What's the x in the diagram? Meg, what's the x in this diagram? Yep, hypotenuse. How about this side over here I'm going to work with? Here's opposite, yep. All right, I got O and H now, Greg. Let's see if you're coming up here. Oh, you got lucky. Paul? Sine? Greg, if I would have called on you, what are the odds you just would have spent out tangent without even thinking?
Well, you mentioned earlier that it wasn't going to be tangent this time, so I picked.
Oh, you heard that. Nice. All right. All right. Way to go, Greg. Picking it up. So, yes, I am going to use sine of 7 degrees. I know hypotenuse is x, but what about opposite here? You guys help? What about this length right here? Hi, Lauren.
Hello. 5,000.
5,200 minus the control tower height. 5,000. Good. And then nearest foot. Foot. Woo! $41,028 feet. Looking good. This last one has nothing to do with elevation or depression. I just want you to relate what we're doing to quadrilaterals. Another unit we've talked about. I am not going to do this one. All I'm going to do is, number one, list a couple properties that you may need here. Rhombus. All sides congruent, yeah. Rhombus.
Opposite sides parallel.
Don't need it. That's true, but I don't need it here. Mahmood. Yes, perpendicular diagonals. That's going to get you your right triangles to use. And one other thing about the diagonals, because it's a parallelogram too, the diagonals bisect each other. So I just wanted a refresh of some of the properties we may need in this problem. You want to work with your group? Go ahead, work solo. Guys, all I'm going to do is give you the answer. When you get to the answer, you can start the homework on the following pages. If you can't get the answer, you call me over. Not in a rhombus, in a rectangle. Not in a rhombus. But they do bisect each other. There you go. 72 and 54 should be your final answers. Do not move on until you get those answers or you call me over for help. Griff, use the beast back here. Best one in the school.